student leave them.
All right. Okay, so as before, what I was saying, page 103, 111, those are due tomorrow. Keep that in mind. The first page is on truth values, true and false. Second page is on writing sentences down and making sure that you have it in the right form. So like inverse, converse, contrapositive. You have to label which one's which, all that good stuff. All right. Let's see. And the thing now. I had it this morning. I got to Joe. Yeah. I had it. Now it's this place. I had to wait this all day and you went missing. Okay. So today, if you can look at the board here, we're doing we're going to talk about algebraic proofs today. This is the last section of the chapter I kind of warned you of chapter 2 for us. Mixing two different sections together, because I said we have two sections left, but they're the same thing, so we're going to mix them together. So that means if we can get hopefully done with this section by tomorrow, we'll have the test as early as next Wednesday, because we'll start reviewing on Monday and Tuesday next week. The reason I want to make sure it's done on Wednesday-ish is so that you have 1 week if you wish to retake it. You can see your scores, you can retake all the good stuff. Now for me, if you have any missing scores, late assignments, whatever you have, you're going to make fixes on stuff. Everything is due by next Friday. Did everyone hear that? Next Friday is the cutoff date for me. The reason being is that that I want you to at least know well in advance by by the end of next week what your quarter grade is, so there's no surprises. So you know, okay, this is what I'm getting because everything was due Friday, that type of thing. You need to be on it. You need to be checking your grade book constantly. I think your guys' grade are completely up to date as of this moment. Everything is in the grade book that should be in there. So if you have an LI or a 0 or an MI, it's because you're not turning something in. So, or you did turn it in, I just marked it as a 0 now because it's way too long. So that does happen, okay? All right, so double check your grades. I'll go through the list today. I'll say your name, you owe me something, or two. Check this stuff, okay? If you need a printout, I'll give you a printout. I can do that, it's pretty easy, okay? All right, I'd like you to write down your outline here. We're talking about the forms of algebraic proofs. We gotta talk about what proofs are in the first place. We're gonna talk about conjectures today, and then we're gonna get into the types of reasoning. And this will help us with what we're going into. My goal today is to go about, 20 minutes or so for notes. And then you'll have about 15 to 16 minutes to kind of work on your assignment today. Because I did give you an assignment yesterday, and I want to make sure you know how to do it. So I'll let you have your notes out, be writing down the outline, and we're going to get started here. Okay. All right. Talk about proofs themselves. Let's go into this. Let's talk about the start of it. Let's talk about what a proof is. This is your starting of the section where a lot of people, when they hear the word proof, they kind of go, I'm going to do proofs. They're not bad. It's just all you have to do is a proof is using deductive or inductive reasoning. So it's the use of inductive and deductive reasoning while showing evidence to make a valid conclusion. about what a valid conclusion is. It's also known as a conjecture. Conjectures are coming up with something that you know is true. That's the idea. So this is also known as a conjecture. Using reasoning to actually prove something. A proof can be as easy as you know, when somebody asks you how to do your homework, and you go through an explanation of it. You try to teach them how to do it. You're actually giving a proof of it. You're giving evidence. You're showing what you need to do. In fact, doing a proof, this is kind of weird, doing a proof is actually the best way to learn something. And what I mean by that is that there's research out there that people that can remember things, fine, that's great, you have really good memory, deductive reasoning, right? But unless you know how to apply it, you really don't ever learn it. The concept is you could read a passage in a book 1 billion times over, but you may not ever know how to use that thing that you've been reading. You just know what the words said, right? That's the whole premise of mathematics, right? Most people they can see an instructor like me standing up front showing you how to do it. You write it down and you kind of look at it, and the day before the test you just kind of stare at your paper okay, this is what I need to know. But unless you use it, you're never really learning it. It's this weird strategy that I've always kind of told people, but they never really, I don't think it ever really sinks in. But the best way to study for a test isn't just to look at the practice guide that I give you. The practice guide is to alleviate your stress, to know okay, this is the type of test I'm gonna have. This is how many questions. These are the types of things I need to know, right? The part that you need to do, though, to make sure that you get a good score is to actually go in the book and try problems out. I don't know why, I always tell people this, but they don't, it doesn't sink in. You should go into section 1 of chapter 2, try a couple of those problems, the things I assigned in the homework. Look back at the homework that I assigned. You can go back on my website and see, or JMC, and see what I assigned. Try a couple of the problems out, see if you remember how to do them correctly. Try section 2, try some of those problems out, try different ones, the ones that kind of look different. I would try the odd ones so you can check the back. And then I would just keep doing that pattern, and as you try them, you actually apply your knowledge, you'll figure out that if you know it or you don't, right? That's the best way to study for a test. It's not just studying your practice guide, staring at the words over and over and over, or cramming the night before the test, because that doesn't apply knowledge, right? That's what a proof is. Proof is the best way to learn something. You have to use inductive reasoning, see the patterns, observe, and then apply it, right? It's not just straight deductive reasoning. It's both types of reasoning. But it's showing evidence. That's tough. How did you get to school today, right? You have to go through the process of it. You have to explain what we did, where you went, how you got here. You have to go through every checklist, right? I got dressed, I got my car, but you're missing steps there. Okay, I got dressed, I had to find my clothes, my keys, I had to find my shoes, I opened the door, shut the door, locked the door, went to the garage, opened the garage door, that type of thing. There's a lot of steps. A lot of people jump. They can see big bullets. What we're gonna be doing is looking at the little pieces, the little things in between that you never really thought of. Oh my gosh, yeah, I didn't have to open the garage door today. Yeah, I probably should have put that. That's a proof. It's looking back at evidence and coming up with a valid argument for what you did, right? That's the best way I can explain it. But a conjecture is a valid conclusion. But it's using inductive and deductive reasoning to do it. All right, now there's 2 types of reasoning. Number 1 type of reasoning is called the Law of Detachment. The Law of Detachment is something that a lot of people do when they want to solve a mystery, solve a problem. What basically the best way I can explain it is you have some type of prior knowledge, some type, and when you have this new problem that arises, you have this new problem, all you do is when you have this new problem, you call back on your prior knowledge, think about, okay, how did I do this last time, and immediately try that same method. That's a law of detachment. You detach what you've already previously learned and apply it to a new problem. So the best way I can explain it, let's say we're doing this whole thing where you get to school, okay? So So let's go. Bob runs out of, Bob's car doesn't start. Bob's car doesn't start. Because he ran out of gas. So that's my sentence, right? I could make that an if-then statement. If Bob's car doesn't start, then it's out of gas, right? That's an if-then statement. So you have this in your head. Okay, your car doesn't start, you ran out of gas. So if later in the day, Bob's car doesn't start. So it doesn't start. What's the conclusion you can make from that if it doesn't start? It's out of gas. That's the first thing that people jump to, right? Like, Bob knew before his car didn't start, he ran out of gas. So later in the day, if it doesn't start again, he ran out of gas. That's the first thing. That's a law of detachment. Does it have to be the actual conclusion? No, it could be 100 different things. Maybe he left the lights on so the battery was dead. But detachment is just taking what you've already known and applying it to a new problem, because that's the only thing you know. You haven't ventured out and thought about anything new, right? Just going after previous knowledge. That's great. Don't get me wrong. Doing a law of detachment can get you a lot of good things, right? Because you think back to the problems like, how did I do something before? Okay, I'm going to try this method again. That's great. But for a proof, sometimes you got to get out of the comfort zone. You gotta get away from prior knowledge, explore a completely different aspect of it. Go look up a couple words. Go look up a couple new problems, and see maybe there's a different way to do it. There's not just one way. Math problems can take a bunch of different ways to solve. But it's nice if you have at least some prior knowledge. Don't get me wrong. Without prior knowledge, some people might not know where to start. So you gotta fall back to something, right? All right, that's a law of detachment. Now, a law of syllogism. All right, a law of syllogism. Law of syllogism. It's where the best way is, I think of like it's a daisy chain. It's a daisy chain of events occurring. I'm going to use this extreme case question.
Okay, what's a daisy chain?
Daisy chain is where something were to happen, and then that causes another thing to happen. It's like a chain reaction. And these all are affecting the previous thing. So you woke up this morning and you had a headache. You went to school, you snapped at your friend. They're just like, it's building, right? It's this thing that it's a one thing causing another thing, causing another thing. It's a chain reaction, right? And you can go back, like, I do this all the time, like, and I don't even mean to, I know I do it. Woke up, had a headache, went to school, kind of snapped at a few people. I do that once in a while. And then you get to home, and then my wife's like, what is wrong with you today? You're like a bear right now. And then I think back, like, well, I do have a headache right now. And I didn't mean to like snap at her, but it was like, yeah, I mean, there's like, if you just think for a few seconds, like, oh, well, duh, maybe I should get rid of the headache first, you know? That does happen, right? Everyone has that. You know, have a bad day, and kind of just boils over. But what a law of syllogism is applying like inductive and deductive reasoning for a problem. So let me explain. Let's say, this is the most extreme case. This is silly, but there's this stupid story that goes around Facebook, and there used to be these websites where they would like do like social like news of the day. I don't even know what you guys use anymore other than Twitter and Snapchat. But they used to have these websites where you go on and you kind of see the weird, quirky news of the day, stuff that doesn't happen to everybody. But there was this one gentleman where he said that he traded, and this is an actual true story, you can go look at this. He traded a paperclip for a Lamborghini. Like an actual working Lamborghini, right? Reading that headline, yeah, it's clickbait, right? Like, oh God, I gotta go check out that. He traded a paperclip for, like, what happened to this guy, right? I sold Lamborghini. But
But the idea was he didn't actually trade the paperclip. It was this chain of events that occurred where it was called trading up. It's this weird trend that happened early 2000s where, and some people were like trying to compete with this, where he did literally start with a paperclip. So here's my paperclip, right? And he traded that for like a sticker, just for his friend. And then he traded the sticker because somebody liked the sticker and he got a pencil out of it. And then he lent the pencil to somebody else for like a notebook. And then he traded the notebook for a can of pop. And he gave a can of pop to somebody for $1. And he kept going up and up and up. And what he did is he kept logging what he was trading. And he did this, he has all the evidence of what he did, what he traded, he had pictures for everything. Because he did this chain where he went up and up and up and up and up, and eventually he landed at the car itself. So there was a bunch of things he traded for. He went to Craigslist, and he was trading, like he was doing that bargaining thing where he's like, hey, I'll give you an Xbox for your motorcycle, like your little dirt bike, and then they traded. And then he kept going up, and eventually he got to his car. Well, the headline read, he traded a paperclip for a Lamborghini. He didn't do that. What you just did is a law of syllogism. You knew what he started with, and you just jumped the line you went to end what he ended with. In theory, he kind of did. I mean, he eventually traded a paperclip and got a car. Do you leave your debit card in here?
I did. I've been picking out last minutes.
I thought I was going to go to the office, but it is good. All right. I feel a lot better. Yeah, card back. All right. So, do you see how like there was a chain of events that occurred? That's a big thing. A lot of people were doing that. I think eventually he traded the car for a house now. It wasn't really, he sold the car, so he said he traded the car for money, and then he used the money to buy a house. So it was like an exchange, but it was still a part of the whole chain of events that are occurring. But a lot of people did this. They're still going, and he wrote a book on it. And this is some like weird cultural thing behind it, but the idea is that law of syllogism is one thing led to another, led to another, led to another, and eventually that the first thing ends with the last thing, right? The whole concept of him documenting, that's a proof, right? Because there's different types of proofs in this world, right? Let me go through the different types. First type is called a paragraph proof. Okay, where you just write in words, and that's what this gentleman did. He wrote a book on it, so it's a paragraph proof. It's actually called an informal proof. It's an informal proof. Okay. Some people like this. They try to rationalize things in their head. It's almost like you're talking yourself into like agreeing with the subject, that type of thing. That's an informal proof. You're coming up with reasons like, yeah, that sounds like a good idea. I should go do that. Question.
How long did it take him to get the car?
It was a long time. Like, that's the thing. Like, you see that, like, that wasn't one afternoon, right? That took him, I think, the better part of like 4 years to do it. But, he was constantly doing it. He was documenting everything because he thought it was funny. It was like a social experiment to him. No one's in the right mind's going to do that because he had to go through all those little stupid things. And I skipped a lot of steps before he got to that car, right? And he documented everything that he did. But he wrote the book on it, right? He said how he did it, what he did, and that's an informal proof. The other types of proofs that we have algebraic proofs. Algebraic proofs, you actually use algebra. You can actually apply algebra to that problem. You could assign values to everything, because I even said at the last point, he traded the car for money. It's not really a barter. He's not trading. Somebody paid him for it, but that's still considered a bargain. And so he got money. Well, you can do that to the problem. You could apply, value, like this paperclip is worth the same as a sticker, which, is the same as a pencil. And you could just keep trading up and eventually see that, using algebra that, he made a fair trade. But then in the end, if you were to apply algebra to this thing, you would say that like a 10-cent paperclip equals a car. Like, is that real? And no. But that's the idea. You can make these crazy assumptions. right? People do that all the time. There's this news article going out right now that Amazon and Apple and Microsoft were hacked by Chinese operatives where they installed super microchips on their motherboards. Right? I don't even know if the story is true or false, but all the companies are like, that's definitely not happening, because somebody made this conclusion. They went to DEF CON in Las Vegas, watched a couple lectures, so they got this information in their head. They talked to some security analysts, is like, yeah, I mean, that could definitely happen. And suddenly the Wall Street Journal Bloomsburg Weekly, this is a big publication, by the way, published that Apple got hacked by Chinese operatives. That's a big jump you just made. In fact, that's an illegal jump. I'm betting on people are gonna get fired if that's not true. And they say they have a bunch of evidence, but no one's coming up with any of the motherboards, and Apple's like, what are you even talking about? No one in Apple even knows, and no one in Amazon, no one in Microsoft knows. And them denying it, if it's actually true, that's like SEC violation. That could lead to a ton of lawsuits and like loss of jobs everywhere in those companies, but they're making like radical jumps. Paperclip equals a car in value. No, it doesn't. That's a radical jump you just made. Okay? But an algebraic proof showing evidence. There's other types of proofs. There's statement reason proofs, and that's the one that we're going to use a lot, statement reason. Statement reason is kind of the go-to version that I like to use quite a bit. And then there's another type of proof. It's one of the hardest forms, is where you start with an opposite conclusion, where the idea that you start with the concept, like if you had a math problem, you start with the concept like the answer doesn't equal 4. And eventually you do all the algebra and you do all the statement reasons, and eventually you're like, well, that can't actually work. Like it definitely has to be 4 in this case for this thing to work. So it's not an informal proof. It's a form of like negation of a proof. It's we're gonna see one of these later, and I'll give you the actual correct term for it. But it's a type of proof where you're mixing statement reasons and algebraic, but you're going backwards through. It's like almost an inverse type of proof. And we'll get to one of those eventually. But this is what we're going into. The goal today is to show you one example, just one, because today is the intro day. I just want an intro, not overwhelm you. I only got about 2 minutes left I want to do here, so I want you to see this. Okay, so here's what I like to do. I know this is going to seem silly. Does everyone have their notes out? Okay, I know you probably haven't written a lot today, but that's the concept. I would like you to write down this problem. 3x plus 1 equals 10. Super easy algebra problem, right? Very, very straightforward. What I'd like you to do right now is solve for x. That's all I want you to do today. Solve for x. But show all your work. Got it? Okay. Solve for x. I'll give you 1 or 2 minutes. This is my last thing today, I promise. By the way, the type of proof I was talking about earlier is called an indirect proof. Sorry, I didn't tell you that. It's called indirect proof. But this, I just want you to try to solve for x. If you can get done with this, then yes.
Oh, there's no hardest problems somewhere. There's a hardest problems. Imagine if we had this on the test. Heartbeat. Wait.
So I'm going to print off this practice test for you, and I know what's going to happen. I'm going to cut this off and find it right after you leave. It's going to happen.
Oh, you're fast. You little man. Don't take this. I'll eat your entire flesh. Wait, I'm serious. I'm gonna eat your flesh. I thought it was connected to my science background.
I
promise you this is my last one of the day. I'm gonna give you 30 more seconds. 30 more seconds. Yes.
And then I dropped it on the chair.
I didn't see any of it because I was concentrating.
No, but you should have heard it.
I should have. I think of like it stays date.
Stays to date.
Stays date. A day's stay. I do that a bunch. I was doing one time I said the turns of table. Oh yeah, one time I said my sleeps the front. I told you that. I'm reading out loud. I did not mean to say it, but I said my sleep's the front.
All right. Okay. All right. Here's my question. I want you to go back and look at your work. How many steps did it take you? That's all I want to know. Raise your hand if it took you 1 step. Okay, good. How many took you 2 steps? How many took you 3? Okay, 4, 5, 6, 7. All right. Okay, 4 is that the biggest number we have? What if I told you it takes 8 steps to do this problem correctly? 8 steps. Doing honest algebraic proof form. That's what we need to learn. Like, don't get me wrong, you probably all have the right answer. I 100% agree, everyone probably has the right answer. I don't even have to check that. But you don't know the steps to prove it. You know the shortcuts you've learned over Algebra 1 and pre-algebra. That's what I'm betting on. You haven't seen all the formal steps. I'm about to show you right now. I want you to write this down. You're not gonna understand it, but I want you to see it for the first time. Okay, you ready? This is an algebraic proof. Line number 1. You're going to add 1 to both sides. That is called the addition property of equality. Yeah, I just abbreviated the word prop. That's property. Yeah, that's the first step. I'm betting on most of you did that. The second part is the hard part. Okay, I should say subtraction. What am I doing? Amateur hour in here? That should be the subtraction property of equality. Sorry, subtraction. Went too fast. All right, subtraction property of equality. So I'm subtracting 1. Probably everyone did that. Okay. Step 2. This is the part I'm betting on everyone different. You get a 0 right here. I'm betting on no one wrote that. You probably just find 1 minus 1 gone. That step right here, making the 0. It's called a property of opposites. Property of opposites. Next part, adding the 0 to a 3x. That's an additive identity. Again, I told you, you're not going to know what some of these words are because you haven't seen them before. When you add 0 to something, it's an additive identity. Next part, I can now take the 10 minus 1 and get 9. It's called substitution. How many steps did it just take me to get rid of the number 1? 4. It takes me another 4 steps to get rid of the stupid 3. It takes 4 lines of work. You've never seen this before. You guys know the shortcuts. Subtract 1, boom, 3x equals 9. Next step, divide by 3, boom, answer's 3. You're skipping 4 steps sometimes when you do it, each time. Next step, divide by 3, divide by 3. That's called the division property of equality. And yes, I abbreviated prop. Property of equality. Dividing 3 by 3, I get the number 1. That's called a reciprocal. It's a reciprocal property. Multiplying by 1. That's a multiplicative identity. And the absolute last step, taking 9 divided by 3, which is 3. That's substitution. Okay, you're seeing it for the first time. I'm not meaning for this to be like, overly difficult. You need to learn the correct process for doing a proof, not shorthand. You guys know shorthand. The good thing about shorthand is you know what the answer should be. Doing this stuff is all the stuff in between, and that's what geometry is all about. Fill in all the gaps of what you're supposed to know, what you're supposed to do, how you're supposed to do it, the reason why. Because what I come back full circle to what I said earlier. To actually learn something, you have to go through a proof and understand every aspect of why something happens. It's like to get to know somebody for the first time. You have to be in their shoes experiencing what they experienced for the first time. And that's the hardest thing for people to understand, is that they make snap conclusions on people, and that's not fair because you miss the 20, 30 steps in between what they go through every day, right? It's the same concept. It's not a life lesson, but I want you to understand what we're going into, okay? Make sense? Okay, I know you probably don't know any of those things. That's what we're doing tomorrow on Monday. Ready? Okay. I scared all of you to death.
Good.